So the next section in Unit 1, the transformations unit, is going to be graphing equations. So graph each function, state the domain and range, and label significant points in a table. So the first thing you want to do is make sure that everything is organized in a way that matches our transformation map, which is going to be A times B times x minus h plus k. Right? And with this first one, we already have that, so that's nice, but there will be a few in here that we will have to make some adjustments. Also, make sure that the x is isolated so you can truly see each transformation. So with this one, we'll have -4, and then we're going to have to factor out the 1/3 so that the x is isolated. Now, what you want to think about here is whatever you factor out, you're going to multiply that constant with the reciprocal. So since we factored out 1/3, we're going to multiply it by 3, so we have -6. And then this is squared, and then plus 5. A way you can double check this is redistribute. We can see that 1/3 times 6 will be 2, so that that manipulation worked. All right, from here we'll draw our transformation table. So we'll have x and y. And then it's a quadratic. Our parent function is x squared, so the key points will be -1, 0, 1, and then 1, 0, 1. All right, from here, we'll apply the transformations. The x transformations, we're going to multiply by 3 and then add 6. So remember, whenever you are manipulating the inputs, the actual transformation is as if you are undoing. So you're going to do the opposite. So you multiply with the reciprocal of a horizontal dilation, and then you're going to add instead of subtract. When we plug in -1, we get +3. When we plug in 0, we're going to get 6. Plug in 1, we get 9. And then for the y values, we're going to multiply with -4, and then we're going to add 5. When we plug in 1, we get 1. Plug in 0, we get 5. Plug in 1, we get 1 again. So now from here, we'll do a quick sketch. We're mostly in quadrant 1. So we'll have, looks like +3, +1, and then +6, +5. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we'll call this 1, 2, 3, 4, 5, 6, 7. +6, +5, 1, 2, 3, 4, 5, 6, and then up to 5. And then +9, +1, 6, 7, 8, 9. And then we'll open up the parabola facing downwards. All right, just a rough sketch. And then it's also asking for the domain and range. So the domain is, we see the arrows going in both directions, so it'll be all real numbers. And then the range, the only transformation that changed our range was the 5 and the negative. So usually it's going to be 0 to infinity for our parent function, but we are reflecting and we are going to add 5. So now the range is going to be -infinity to +5. Or you can say that y is less than or equal to 5. So either one of those will work. All right, moving on to example 9. Again, we need to make sure that the x is isolated, so I'm going to factor out that 2. So we'll have 3 divided by, factor out the 2, x plus, again, I factored out a 2, so I'm going to multiply with the reciprocal, which is going to be 1/2. So 2 times 1/2 is going to give us 1. And then I'll complete that, and then subtract 1. So our parent function is going to be 1 over x squared, and that looks like this, right? And then remember, all rationals have 2 asymptotes, right? So our transformation table has to show those asymptotes in there. So we'll have x, and then we'll have our y values. So for this one, we have 2 key points. We're going to have -1 and +1, and because it's x squared, they're both going to be positive. And then we have our vertical asymptote. Vertical asymptote means that x is equal to 0. And then our horizontal asymptote is going to be y is equal to 0. So applying our transformations. The x transformations, we have a b value of 2. So we're going to use 1/2. And then we have +1, so we're going to do -1. When you plug in -1, we're going to end up with -1/2 minus 1, which will be, we'll call that -1.5. If you plug in 1, we have 0.5 minus 1, so that's going to be -0.5. And then for 0, we'll have -1, which is our vertical asymptote, and then your horizontal asymptote is still going to be your horizontal asymptote. For our vertical transformations, we're going to have a vertical dilation of 3, so 3 times y, and then we have a vertical translation of -1. So when we plug in 1, we're going to get 2, and then our vertical asymptote is still the same, and then our horizontal asymptote will now be at -1. So for your horizontal asymptotes, your vertical translations can only change those. For your vertical asymptotes, your horizontal translations will change those. So graphically, let's start with the asymptotes. I'll get some ticks on there. Boom, boom, and then 1, 2, 3, 2, 3, and then 1, 2. So our horizontal asymptote is at -1. Vertical asymptote is at -1. Key points are at -1.5 and 2. Whoops, use a different color. And -0.5 and 2. And then from here, it's going to go upwards. Okay. So for this one, the domain is all real numbers except for x cannot equal -1 because of that vertical asymptote. And then our range is going to start at -1, but it's not inclusive because of the vertical asymptote, to infinity. Or you could say that y is greater than -1. So that's number 9. Number 10, we have 4 minus 2 times the square root of 6 minus 2x. So we need to rewrite this so it matches our transformation map. We'll have -2. I have the square root. I'm going to rewrite this so that the x is the first term. -2x plus 6, and then we have our plus 4. So that's just so I can see all the transformations clearly. Now from here, again, we need to factor out that -2. So I'll factor out -2. We'll have x. So I factored out a -2, so I'm going to multiply that 6 with -1/2, which is going to give me -3. And then we'll have plus 4. Okay, so now from here we can start our transformation table. We have x and y. And for the square root, your x values are going to be 0, 1, and 4. Your x values should be numbers that you can take the square root of, and then you end up with a whole number or an integer. So the square root of 0 is 0, square root of 1 is going to be 1, and we don't want to use 2 or 3 because they're not whole numbers, so we can use the square root of 4, which is going to be 2. All right, applying the transformations. So for our x, or our horizontal transformations, we'll have -1/2 using the reciprocal, x plus 3. Plug in 0, we get +3. Plug in 1, we have -0.5 plus 3, which will be 2.5. And then plugging in 4, we have -2 plus 3, which is 1. Vertical transformations, we'll have -2 plus 4. -2y plus 4. Plug in 0, we get +4. Plug in 1, we have -2 plus 4, which is 2. Plug in 2, we get -4 plus 4, which is 0. So graphing this one. All right, so the first point is at 3, 4. So we'll go 1, 2, 3, 1, 2, 3, 4. 2.52, and then 1, 0. All right, so there might be some confusion on, okay, do we go this way? Do we go this way? If you think about the parent function, it starts at the origin and then it grows in the positive direction, okay? We have two reflections being applied to this. This first reflection is going to reflect the y values, so now it's going to be going this way. This other reflection, that is reflecting the x values, so the part that we already reflected is also going to be this way. So that means our origin or our starting point is going to be the top point, all right, which is going to be here. So when we draw this curve, it's going to look like this. It's the printer, sorry about that. All right, the domain for this one is going to be -infinity, and then our ending point is going to be x equals 3, and it's inclusive. Or you can say x is less than 3. The range, the maximum is going to be that same point, so it's at 4, so we'll be at -infinity to 4 inclusive, or you can say y is less than 4. Okay. Number 11 is going to be our absolute value function. So with this one, again, we want to isolate the x, so we're going to factor out the 4, and then we'll have x minus. We have 4 that we factored out, so we want to multiply the -2 with 1/4. So if we do -2 times 1/4, we get -1/2. So that means we're going to have x minus 1/2. All right, so we're good here. All we have are x or horizontal transformations with this one, so that'll make this a little bit easier. So for the absolute value, it's similar to the quadratic. It is even, and it's going to have all positive values. So we'll have -1, 0, 1, and then 1, 0, 1. Transformation for the x, we have a 4, which means we're going to multiply with, actually, I believe we changed this one, but I'll keep going with this one. I think I had 4 minus 2x, but we'll stick with this one. It's fine. So with this one, we're going to have 1/4 x plus 1/2. All right, so if we plug in -1, we get -1/4. And then plus, I'm going to rewrite that as 2/4, so we end up with 1/4. Plug in 0, we get 1/2. Oh, I see why we changed it. These are really tiny values. And then when you plug in 1, you get 1/4 plus 2/4, which is equal to 3/4. And then we don't have any vertical transformations. Okay, so this is in quadrant 1, so we'll zoom in a little bit closer for that one. So we'll say that this is 1/4, 1/2, 3/4, and 1. So this is 1/2, and then this will be 1. And then we'll have a y value of 1. So at 1/4, we're going to have a value of 1. And then at 1/2, we'll have 0. And then at 3/4, we're going to have 1. So we have that absolute value function here. All right, domain, it's an absolute value, so it's going to be all reals. Or you might see -infinity to +infinity. And then the range is going to be from 0 to infinity. 0 to infinity. Or you can say y is greater than or equal to 0. All right. Number 12, f of x is equal to 7 raised to the 5 minus x plus 1. So again, I'm going to rewrite this so that my x is the leading term. The exponentials can get a little tricky because your x transformations are going to be here. They're going to be in the superscript. And now from here, we still want to isolate the x. So I'm going to factor out a negative. So we'll have x. When I factor out a negative, I'm going to multiply this with, it's the same thing as dividing by -1. You'll multiply by -1. So we'll have x minus 5 plus 1. That way, when we distribute this, we still get the plus. So that's a way to check that. All right, transformation table. So 90% of the time, okay, I don't know if it's actually 90%, but highly likely that you'll get -1, 0, 1. Like even with these, we saw it on example 11 and example 8. So I guess we'll say not as high as 90, but pretty high chance. All right, so with this one, just plug it in. Our parent function is going to be 7 raised to the x. So if I plug in -1 for x, I get 7 raised, I'll put it in the table. 7 to the power of -1, which is equal to 1 over 7. If we plug in 0, anything to the power of 0 is 1. If we plug in 1, it's just going to be 7. All right, our x transformations, we have a reflection and we are subtracting 5 with the isolated. So a reflection and reflection and then we are adding 5. So we'll have -x plus 5. So make sure the base, the parent of this is the 7x. So you don't want to see the 7 anywhere because it's already our base. That 7 has contributed to the transformation by being our key points. So nowhere should you have the parent function inside of your horizontal or vertical transformations. What I notice sometimes is that, which one is it? This one here. People would try to rewrite this as, okay, this is 1 over x squared times 1/2 minus 1, all right? The parent function already contributes by being the key points. And then you're basically doing double jeopardy by applying it again, so you're not going to get the proper graph. So whatever your parent function is, it should not be showing up in your transformation table up here. It should only be your key points, okay? So be careful with that. The transformations here should either be multiplicative or just adding and subtracting. So if we plug in -1, we get 6. Plug in 0, we get 5. Plug in +1, we get 4. Now, exponential functions, I missed something on this. Graphically, it's going to look like this. But all exponential functions have a horizontal asymptote. So the horizontal asymptote for the parent function is going to be y equals 0. So I want to include that in the y column. All right, so the horizontal asymptote will stay the horizontal asymptote over here. And then again, the only thing that changes a horizontal asymptote is a vertical translation, okay? So it's going to be that +1. So we just have y plus 1. Again, it should not be 7y, that's the base. It's not a vertical dilation, so it's just y plus 1. So from here, 1/7 plus 1 is going to give us 8/7. 1 plus 1 is 2, 7 plus 1 is 8, 0 plus 1 is just 1. All right, graphing this, we're a little bit further into the first quadrant. Okay, so at 6 we'll be at 8/7, or just above 1. 1, 2, 3, 4, 5, 6. And then at 5 we'll be at 2. So 1, 2, 3, 4, 5. And then at 4 we'll be at 8. So it's going up a little bit higher. And then we have our horizontal asymptote at 1. And then that's approaching, and then from here, it's just going to infinity. Or coming from negative infinity, I should say. All right, so the domain for this, it's exponential. So it's going to be all reals. And then the range, we're going to use that horizontal asymptote. We're going to go from +1 to infinity, or you can say y is greater than 1. All right, last one is a logarithmic function. Okay. So with this one, we just have to factor out that 0.4. So we'll have negative log base 3. I'm going to factor out the 0.4. And then we'll have x minus. So if I'm factoring out the 0.4, I want to multiply this with 1 over 0.4, which can get a little confusing. So I'm going to rewrite this as a fraction. So 0.4 is equal to 4/10, which is equal to 2/5. So if I come back to here, I'm going to just write in 2/5. So sometimes you have to play between decimals and fractions. Some of these are easier with decimals, some of them are easier with fractions. So I'm going to rewrite 2/5, and then I'm going to have x minus. So I want to multiply it with 5 over 2. So 3.2 times 5 over 2. This is getting a little weird. Let's see. If I divide this by 2, the 3.2 by 2, 32 divided by 2 is just 16, so that'll be 1.6 times 5. So let's see. Oh, I'm doing this all crazy. I don't need to do all that. Hopefully you saw it before me. There's no excuse. I'm a little tired, but it's just the end of the day. So if we just do 3.2 divided by 0.4, that's just going to give you 8. So if we move the decimal over, we get 32 divided by 4, it's just 8. So I'm just doing some weird stuff in there. Sorry about that. So it's just going to be x minus 8. All right, transformation table. For log, and I'm glad the exponential is over here, it's going to be the inverse of that. So we will switch our x and y values. So I'm going to go -1, 0, 1. And because log is the inverse of an exponential, instead of having a horizontal asymptote, we will have a vertical asymptote. So now I can still use this, like what I did over here, except for this one, the parent function for the exponential would be 3 to the x, because that's the base of the log. So if I plug in -1 in for x, I get 1/3. If I plug in 0, I get 1. If I plug in 1, I get 3. And then the vertical asymptote is at x equals 0. So usually it's easier to remember the attributes of exponentials than logs. So you can use the inverse relationship in order to get the transformation table for your logs. And again, for this one, all we have are the horizontal transformations. So we have 2/5, so we're going to multiply with 5 over 2 instead, x, and then we'll add 8. All right, if we do 1/3, we have 5 over 2 times 1/3, which is 6, and then we'll have plus 48 over 6. I'm just multiplying. So that means we have 6 plus 48, which is going to give us 54. 54 over 6. So that means we have about 48. Hold on, I think I did that wrong. So our denominator is going to be 6. And and then we'll have 48 over 6. Oh, it's 53. 53 over 6, which is going to be about 8 and some change, okay? So this will be 8 point something, or I can say 8 and 5/6. That's what this is. So graphically, it'll just be almost to 9. If we plug in 1, we get 2.5 plus 8, which is 10.5. So the decimals are easier for that one. If we plug in 3, it's 2.5 times 3. So we'll have 6 plus 1.5. So that'll be 7.5. So 7.5 plus 8 is going to be 15.5. And if we plug in 0, we get 8. Okay. So this is the lowest x value is 8, which is our vertical asymptote. So I'm going to crunch up the x-axis a little bit. And then this will start at 8. And then I'm going to double it up so we can get to 16, 10, 12, 14, 16. This will be 1, and then this will be -1. All right, so the first point is 8 and 5/6, and then it'll be at -1. Oh, we do have a vertical transformation. Okay. Sorry about that. So it'll be -y, and it's just flipping the outputs. So we'll have +1, 0, -1, and then our vertical asymptote. All right, so at 8 and 5/6, we're going to have +1, so almost to 9. At 10.5 will be 0. And then at 15.5 will be at -1. And then we have that vertical asymptote at 8. So it's going to look something like this. The domain is going to be, since it starts at 8, we'll have 8 to infinity. Or you can say x is greater than 8. And then for the range, it will be all reals. All right, so these are all pretty different, but the approach is the same. Rewrite your function so that it matches your transformation map. Figure out the parent function, and then apply the correct transformations, graph it, and then find the domain and the range. All right, thank you. Hope this helps.